Artlist.io. Artlist.io. Music licensing reimagined. Artlist.io. Music licensing reimagined.
Hello, everyone. I hope we are online for now, and let me say hello to all our global audience. We're happy to be here today with you. You know, our community is so young. It's our just third event as AWS User Group, Gdansk or Tri-City, Trimester. And yeah, thanks a lot for all of your support. Thanks a lot for our sponsors. You can find really great opportunities here and follow our user group network, social networks here. Stay tuned for the next events. And let me pass the through for my colleague and co-founder of our user group, Boris.
I'm also glad to see everyone here. And I want to say that I'm very happy that we're growing every time, and now we're part of the global AWS community of 170 groups around the world. I hope we grow more and more and give more influence on AWS knowledge in our world.
Yeah. As usual, guys, let's grow our community together and hope you will enjoy our today's event. And briefly, let me remind you of the agenda. We will have two parts. First speaker, then short break, pizza break session. Then our second speaker will present his presentation. And then for our offline audience, we will have Kahoot quiz, when you can have a chance to win AWS credits and some gifts from our community. Okay, let's do it. And let me introduce our first speaker. It is Kirill Solovei, Senior Systems Engineer at Epam Systems. Kirill, very welcome.
Yeah. Hi, everyone. As Anton already said, my name is Kirill, and today I'm going to show you and get you acquainted with my experience of using AWS RDS, and specifically database migration. So let's start with a quick survey. How many of you actually know what RDS is? Okay, quite a lot. And how many of you have heard of DMS? Yeah, my condolences to you all. Well, what is DMS? As stated by Amazon, this is this kind of silver bullet which helps you to migrate database from one source to another. It may be either on-premise database, in my case, or for example another RDS or even database living on an EC2 instance. This how Amazon describes the whole process of migration. As you see, looks quite simple. I mean, what can engineer possibly hope for when migrating this complicated stuff as database? This is the honest schema of database migration system. And as you can see, it became much more complicated. For example, some things as source, target endpoints appeared, and some kind of replication task. So in order to migrate database from one source to another, we actually have to create a few things, starting from source and target endpoints. In this case, source and target endpoints are connection settings that allow you to connect to source database and respectively target database, which includes host name, port, database password, things like that. Replication task and replication instance. So let's talk a bit about replication instance, because this is actually the most important part in the whole migration process. It is an EC2 instance that actually performing all the operations of migration. It does all the heavy lifting. Replication task is the a number of settings that allows you to describes which tables migrate where and what to do with them. For example, transform schema or leave it as is, settings like that. And this is the more detailed picture of how migration actually performs. As you can see, it's not so easy as was over here. But we gotta do what we gotta do, you know. Replication task is the most interesting and the most complex thing over here. This is how replication task setting looks like. In my opinion, these are not very interesting fields because they are just describing where to connect and what to use during the migration. So let's move a bit further and take a look at the interesting settings, which are as follows. The ones we are more interested in are table preparation mode and LOB column settings. Well, I don't know about you, but when I first opened this stuff, I was like, what is LOB? Who even needs it? Huh? Exactly. But why do we need them? That's a question for another presentation. So I would say that these settings may be useful because apart from actual migration, AWS DMS actually allows to set up replication, ongoing replication from one instance to another, in which, in this case, those settings come actually very handy because, well, when you set up replication, you do not want to truncate the existing data. Well, let's move on. And this brings us to the actual task I have been working on, and from where I started and where I want to be eventually. And this is stuff I had. There were a couple of databases, actually 2 of them. The one with the production data and the other is for development. Each of them had approximately 100 gigabytes of data. And somewhere around 150 tables each. And you know, well, all the stuff that also required for databases like indexes, primary keys, foreign keys, all that not interesting settings. And where I want to be, well, you know, the cloud, as stated in the title of the presentation. And this brings us to actual migration and my first try of this in order to perform the actual initial task, these are the points I had to come through. Well, I already had source database, so I created a source endpoint for it. I also created RDS instance and endpoint for it. Replication instance, as I already said, was prepared for this stuff, and all I had to do was start the replication task. Well, I did, but unfortunately it failed almost instantly because I forgot about security groups. Fixing that small issue, this is where the fun begins. Unfortunately, my luck was not very lucky. And this error was, it happened during switching from on-premise database to RDS. And we had to quickly switch back because it's not working in this state. And let's take a look at the differences and why it happened. As you can see, this is the schema for initial table I had. And this is what I got on RDS after the migration. Maybe you already see the differences, right? For example, why is there only one index instead of 3 over here? And where are the default values? I mean, what happened? Why RDS DMS didn't do what it was supposed to do? That is the step when I came back to documentation and started reading it. And it seems that foreign keys and other constraints on PostgreSQL databases are not migrated by these servers. And I had to know it from the hard truths of executing the stuff without knowing it. Well, it's not very pleasant, but I still some hopes had in me on the future of this process. As you remember, I already said that during the creation of replication task, there are actually a few options you can tickle with, given LOB size, as the gentleman already said, and table preparation mode. What I had in mind that what if I somehow messed up and created RDS instance with some predefined data? What if I choose not only do nothing on the very beginning, but for example, drop tables on target? Well, long story short, it didn't help. Another wonderful error I got in the process of tickling with these options. If you have heard about DMS, you most likely have heard about such thing as schema conversion tool. Well, this is how the interface looks like. I don't know about you, but the first time I saw it, I was kind of horrified because the interface of database for me looks like this. And this one doesn't look like anything to me. But if we take a closer look, it's not so horrible, and we have source and target database on the sides. We have notifications and information at the bottom, at the top, and in the bottom there is object metadata and object schema. Kind of neat. Well, eventually it turned out. So I knew that schema conversion tool is presented by AWS as this another magic tool that helps you to migrate complex situations. So, I mean, if I use it, everything is going to be all right, right? I wrote down some options I had for this task and started to apply them one by one. Well, as you can see, The first one was the best and the easiest one, to just press play and hope that everything will work. It didn't. The second one was that instead of migrating everything at once, I would migrate the schema first and apply data transactions later. Well, it also didn't work, because it turns out that constraints are still there, and you cannot just migrate all the schema and then try to apply transactions, because on some transaction you will experience an error that says that some other constraints from other table disallows you to do that. Okay, I thought, what if I will migrate them one by one? Well, my idea was that if I will be more gentle and do not try to push everything at once, it will somehow happen. It didn't. But first approach on table by table migration was alphabetical, even keeping in mind that there were only 150 tables at the start. It was not the best approach, but still, it could be bearable. So when it failed, I decided to, what if I find the very first table, which has no dependencies on all the other tables, and try to migrate data first. Try to migrate it first. Well, schema, data, yada yada yada. It worked successfully for some time, until I discovered that some situations, some tables require simultaneous constraints from a couple of others, so I couldn't proceed with this approach, because I eventually caught up the same error that says that some constraints stop me from applying more migrations. And there was the last approach I had in mind, the migration schema at first, then apply all the data, and then try to apply constraints to the selected tables. It seems like a good idea. I still think it actually is, but I found the very unpleasant fact that when you try to apply some statements on the pre-existing data, it just wipes them. So no data, no constraints, no tables, nothing. As you can see, here I pointed out the available options I had overall in the scope of this task, like migrate from scratch, a schema conversion tool, yada yada yada. So it took quite a huge amount of time. So in order to switch my scope to something else, I took a week off or something like that, and just rested and let it all settle down. And this brings us to the final part of achieving the success. Here is the amount, is the list of SQL statements I had to perform in order to migrate everything. I started with dumping SQL schema from source database with pgdump, writing them all in separate files on based on their scope, like unique values, index values, foreign keys, defaults, etc., and apply them one by one. The order was as follows. As already said, I dumped the schema. I applied the schema to target database. And after that, I migrated all the data using schema conversion tool. But in this case, I only transferred raw data without any separate statements, so I could specify the error if it will happen. After that, I took all the previously mentioned constraints and apply them one by one, starting from indexes, primary keys, foreign keys, uniques, blah, blah, blah. And actually in the process, I found out that all these constraints are very funny, and some of them are my favorite. For example, the sequences. Maybe some of you know what the sequences in PostgreSQL are. Never mind. The sequences are small functions that auto-increment some values. For example, it is very handy in the cases when you have auto-incrementing ID and you do not want to adjust them every time. It worked. Surprisingly, it worked, but okay, no one knows what sequences is, so I will just say straight up, because during the migration, sequences starting from the 0, and during the migration process, no transactions has been applied because I applied constraints after the data migration. So it turned out when I have source database and target database, the difference between sequences is that on source database they have some specific number, and on target database they have 0. Well, because of course after all the transactions are applied, there is nothing more to increment. So I had to improvise and dump all the sequences values from source database and apply them to target database. It actually happened a couple of times, because before final migration we have to double check and just to reapply the new values from existing one, and it worked. After a month or so working and struggling with this task, I finally achieved success during this whole complicated, convoluted process. And I had some thoughts about it, because it turns out it is not so straightforward and not so simple as Amazon presents it. So I would like to share with you some ideas I had during this whole process, and they start with documentation. Have you seen documentation in Amazon? I mean, at least one. Yeah, I mean, this is the most interesting situation when you have like gigabytes of data, of texts, with actual helpful information counts as a very small amount. So what I would like to share here is that the most important things, in my opinion, when you start to perform some complicated task, is to search first and foremost for constraints, complications, troubleshooting, and prerequisites. Most of the time, they will allow you to keep these things in mind when you actually will start to work on actual process. And when you will stumble upon an error, which you absolutely will, you will already know that it has been pointed out somewhere, and you will have this opportunity to fix them earlier. Unfortunately, I had to realize that silver bullet, as Amazon describes every service of it, doesn't exist. Magic doesn't work, and there is no secret ingredient for just do the magic and it will appear just as you want it to. I think this is the most important thing I realized for myself, because when you are starting to work on some task, you have this kind of cloud of ideas which you apply one by one, and after some time you may forget all the ones you have already used, and you can switch to some other, and forgetting the first ones, you will turn back to them once again, thus wasting the precious time. So if you will start working on some complicated task, have a list by yourself that will point out all the ideas you have for its execution, and just write cross out the already applied one. It will save you some time. It will save you a lot of time, actually. And it will help you to understand the scope of problem you have already been working on. And this gets us to the last point, that actually switching perspective and taking a step back and maybe taking a week off to let yourself rest a bit and get rid of concentrating on one task will help you to see other possible solutions there are for the problem you're working on. It's not a rocket science, I mean, everybody knows that, but still it's a nice idea to remind ourselves once in a while that these things still work, even if everybody knows them. So that's it. Thank you for coming to my TED Talk. Maybe you have questions, you can ask them. And this is my LinkedIn. I see you. Downtime. Actual downtime was quite few because they worked separately. I had initial database already working, and all these preparations, they were performed on a separate instance. So switching was actually extremely fast. It's just update configuration file and reload it. That's it. Yes, there were some bumps during the process because, as I already stated over here, this error and this one, they actually happened during first tries of switching the database, because we had to test it on a production workload. Development, unfortunately, didn't had this amount of requests on it. So you also had a question about maintenance window. Yes, there they were. Here is migration. There is a setting, migration type. It allows you to not only migrate existing data and leave it as is, it also allows you to migrate existing data and continuous changes, thus effectively creating read replica. So the data were consistent. It also can be switched to just copy and leave it as is, but yes, in our case, we migrated existing data and left the replica in read-only mode.
Final question about loadings for this database. How many IOPS? Just interesting.
I don't remember. Unfortunately, the task was on this day is already a year long, and I didn't record anything for it at the moment because I didn't knew it will come in handy eventually. I don't think there were a lot of IOPS because it uses the same EC2 instances, and we did not have a very huge one. I think it was something like 200 gigabytes of GP3 EBS, and that's it. So not a lot of specific technical parameters here. Sorry. Any other questions?
how much time took this migration? I mean, find final solution.
In the actual migration process, the data migration, right? Well, I mean, I think it took approximately 2 days, but on not very high speed. So, but the whole migration plus thinking took around a month. Yeah. I mean, have you? Yes, as it stated. Yes, as it stated in AWS description of service, you just press click and it works, but it isn't. Yeah, this is why I had an idea to, to share actual experience how it doesn't work as they state. But yeah, it's not working. I mean, take a look at the documentation, and this is only starting, and it has even more down there. It's a extreme amount of data which you have to read, but helpful information, quite a few. Any other questions? No. Well, I can, they can't.
Ras. Hello. Yeah, thank you for sharing such wonderful experience. We had pretty the same, but the opposite direction. We migrated to on-premise. And I have a lot of questions, to be honest. Yeah. And first of all, did you dry run your final migration using production data? Or it was one shoot, one migration?
No, there were 2 databases, as I stated, one development and one production. But development database migrated nicely, but the issue was that I didn't know about all these constraints at the moment. Well, I knew that there were indexes, foreign keys, primary keys, etc. But for example, I didn't know that custom data types are also have to be migrated manually, or sequences. So the initial migration didn't show any absence of any of these settings. That's why development migration went nicely. And we'll be like, yeah, come on, let's do on production. And we unfortunately experienced errors stated over there.
So, okay, it was not one shot. You started initial migration in production, then face some issues, fix them, and then repeat, and then repeat.
Yes.
Okay.
Iterative approach.
Okay, got it. And yeah, and another maybe important question. So database was quite big.
Is it?
No?
I mean, it was, oh, sorry, the wrong direction. It was approximately 100 gigabytes and 150 tables. I wouldn't say it is
okay,
quite
it's
big.
not big.
Yeah?
Okay.
I'm used to working with terabyte size tables, so maybe.
Okay, and final question. So is it, from your point of view, is it possible to automate everything from point of view, not doing anything manually by any automation tools or bar scripts, doesn't matter, but not to run anything?
It is, but it will require a significant amount of preparations. You will have to automate applying of all these constraints before migration actual data. You will have to apply some predefined settings, which are also have to be kept in mind. Well, if you are performing initial migration and then you want to automate on top of that, it may be easier. But if you will have to retry this process, it is possible, but it's very complicated in my opinion.
Okay, got it. Thank you.
Sure. Anyone else? Last chance. Okay, I think that's it.
Didn't you try to find some help from community?
No.
Or this is all your solution?
Uh,
So this is as a addition to you can't solve with using documentation. So try. Why didn't you try to use others' help?
Actually, it was used with the help of Stack Overflow. Yes. I
So
think
there were some this this kind of as you problems for everyone, for someone.
Can you please
So
repeat that?
or there's a specific problem you have, or someone also have the same problem with the mails.
No, it's not specific. This is a very common issue because I think a lot of people who have experience with RDS stuck on the same issue with DMS specifically, that you think it's very cool and then you realize it's not so cool. Well, that's why people like us coming to Stack Overflow answering questions. You know, someone have to start somewhere, and it's neat that someone already experienced it. And yes, I did get some help from the community. Well, the white community, not specifically AWS. So yes, that's answer to a question.
And this is why we're sitting here and sharing this knowledge, yeah? Okay, guys, any other questions? We have a couple more minutes before pizza will arrive. If maybe one last, and we will have a short break. Yeah, sure.
Thank you for conversation. It's really amazing because I had the same experience, but I've decided to don't waste my time. For a month, I've lose about 2 days and decide to move with MySQL dump, just dump, and make replication, because you know that's when you have such amount of data, it's not convenient to use database migration service because you can lose your network connection as well, yeah. And the second place of this, let's say, procedure is you cannot replicate, for example, your functions, yeah, because in the master server it's increasing during production workload. And I believe that native tools, it's for now it's still a really convenient way how to replicate all data and enable replication between databases. I'm sorry.
And where's the question?
So the question is, how do you think is it possible to use MySQL dump to together with DMS to be sure that everything is going right, and use DMS server as a replication server as well?
Yes, it is possible, and actually I had to eventually come to this conclusion. As I stated in this presentation, I used pgdump for schema dump, but I didn't want to use to dump the whole database and apply the dump to target database, because it will create downtime on the source database for during some huge table dumps. So I had to be more gentle in this regard. And talking about native tools for tasks like this, you're absolutely correct. They are cool because eventually in the overall, this is the same database. It is the same EC2 instance working somewhere, and you can connect to it the same way you can connect to source database. But I mean, they did this stuff for some reason. Why don't we use it? And then create a presentation for so many people. Kind of win-win. Okay, that's it. Thank you once again for your attention.
I think big thank you to our speaker, and now we have a short about 50-minute pizza break. Pizza waiting you. You can go.
online audience, and we hope next time we will try to organize something. But yeah, now guys, we'll have a short break, 15-20 minutes, and for our global audience, probably we'll listen to some nice music, and we will back. Thank you.
I'm glad to introduce well-known into narrow societies, senior developer advocate from AWS, Viktor Vedmich.
So warm welcome, thank you very much. Yeah, and we are going to start our second session. Thank you, Boris.
Thank you.
Yeah, hello everyone. Well, no, so anyway, just like my name is Viktor. I'm from AWS. Originally, I'm from Belarus, from Minsk. Currently, I'm based in Germany, in Munich. And you know, just like Roman said, like very interesting topic. So you know, before I joined to AWS, I work as a system engineer or DevOps engineer in Epam more than 10 years. So I got a suit like which I currently use to travel between different countries. And yeah, today I'm going to speak with you about this stuff. It's my agenda, you know, like when I prepare my talk, I said like for myself, I have to do some research. What's the current state of DevOps on the market, and why everyone currently to speak about platform engineering? At platform engineering we replace DevOps, or it's like new hype and so on. What's exactly happened? So I know Kirill, for example, used the same tool to draw this fancy, interesting Canva. It's Obsidian. If you want to create your own, yeah, thank you very much. If you want to create your personal knowledge, so Obsidian, it's the best tool. It's not advertisement, but like my personal opinion. So, but before we start the presentation, I have very important and serious question. What's the answer to ultimate question, life, the universe, and everything? Who knows the answer? 42. You're absolutely right. 42, it's the right answer for everything in life. But if you ask me personally, I mean like, what's the number in my opinion, like what's the answer in my opinion, I would say it's 7. And let me explain why 7. So, you know, more than almost 50 years ago, Miller did huge research related how much we can put in our head and remember it. And you know, a magic number, it's a 7. 7 plus minus 2. So I call it Miller wallet. It means like what you can put in the wallet and remember. And why it's so important for my talk and why it's so important for platform engineering and in general for development, because when you start develop your own application, when you work with your code, with your classes, for example, Terraform, Java, doesn't matter, you call, for example, variables. You use some abstraction, interfaces, and so on. And we create all of this stuff to minimize cognitive load on our head, how much we can put in our head and how much we can proceed at the same time. So 7, it's a magic number. Please remember this number because you will see a lot of times this like 7 plus minus 2, 9, maybe 11, something like that. And you know what's interesting also fact that when I said this number to my wife working as UX UI designer, she said, Vita, you're not right, because in UX UI it's number 5 plus minus 2. Because when you create, for example, menu or a user journey, it's gonna take more than 3-5 steps for a person. Again, it's like how much we can put in our head, how we can understand what exactly currently happened. So the ultimate answer for any questions like 42, but my personal favorite number is 7. Let's back to 25 years ago. what we remember 25 years ago? Everywhere was monoliths. We create only monoliths. Nobody cared about microservices. It's like only started to, some people started to think about how we can work with this huge amount of work and so on. But for example, we have, I don't know, like 100 people who develop one of applications. This application can be, I know, like Microsoft Office or some game during 2 years. And after 2 years, demonstrate to our end user, to our customer, get the feedback. And feedback is like, it's not what I expected. So, but sometimes when I try to explain for people what's exactly monolith, it's not only related to the application, guys. Because if you look at another way monolith, it can be, for example, you have one CI/CD pipeline, which you have to trigger when you make any changes at any services, microservices. For example, you have 10 microservices, and when you need to run, you need to get feedback about your unit tests, coverage, integration test. Anyway, you have to run the same release pipeline, for example. Yeah, it's also monolith, but in CI perspective. Or for example, when you want to release your new application, it can be we are dependent from some another, like for example, from QA team. When I said QA team, I mean, for example, I deliver a new version and waiting for response from quality engineers that they confirm that it's good and we are ready to proceed to the production. It's also monolith. And people started to create microservices, thinking that like we have to decouple our application. We don't need to create so many dependency. So microservices stay almost everywhere. So, but almost at the same time, not like at the same time, in 2009, DevOps as a word appeared in this, I mean, like in this planet. And DevOps is like, everyone's like, DevOps will solve all of our problems. I still remember the time when I populate DevOps in Epam and create a user group, also like community, and DevOps was everywhere. Everyone want to DevOps specialist, engineer. But in my personal opinion, DevOps engineer does not exist. And let me a little bit explain what I mean, like what exactly DevOps. Because when I say like DevOps engineer is like unicorn, who knows almost everything. I still remember I tried to apply to one of the position, and the position requires like you have to understand good understanding of database, like migration, almost everything. You have to write the code on the Java. You should know about front end, CI/CD, of course, Ansible, Terraform, all of the stuff, and it's only one person. No, so it's not possible, guys. So it's also related to cognitive load, how much we can put in our head. If you ask me personally what's exactly DevOps for me, I would say it's methodology, how we develop application. And it contains of 3 main parts. The first one, it's people, it's you, how you organize in the teams. The second one, it's a process. What kind of process of development do you use to develop your application? And the third one, it's products, or I call it like tools, technology, doesn't matter. For example, you are going to implement infrastructure as code. Maybe the best solution will be Pulumi or Terraform, depends just like what HashiCorp announced like 1 week ago. So it's up to you, but anyway, products, people, and process. And the main goal of DevOps is try to solve the problem that developer want to release new functionality. They have new ideas, like, I don't know, let's implement dislikes in our Instagram or do some new fancy stuff. From another part of the world, it's operation guy who said, it works, does not touch, please. So, and it's always like a conflict, new functionality or stability of my production environment and so on. So DevOps try to solve all of this stuff and say, hey, we have currently Infinity, that's when we develop our application, we have a build, code, plan, release, deploy, operate, monitor. And mostly you should do by yourself, like as a team, as a group of people. And our CTO, Werner Vogel from Amazon, it's CTO for the whole Amazon. I mean, like, AWS is a small part of Amazon. Yeah, so the whole Amazon CTO, Werner Vogel, said, you build, you run it. So if you create application, you have to be responsible for the whole life cycle of this application, project, service, doesn't matter. But how we do it? I mean, like how exactly we try to implement and how we scale? The main answer, in my personal opinion, is 2 pizza teams. So today we had like 15 pizza, and it was enough for so many people. What's exactly 2 pizza team? Again, it will be related to 7. Around 7 people, it's 1 team. It can be 9, it can be 11, it can be 12, it depends. And this team is fully have whole freedom. I mean, like if you want to select Go as backend for language, please go ahead. If you want to use new CI/CD tools, please go ahead. And this team, it means like fully freedom. Also bring like you're responsible for that. You build it, you run it, and in my personal opinions, it's like how AWS, how Amazon scale. And sometimes people ask me how many people works for some service. Like for example, S3 is a good example. You know, in reInvent 2022, like last reInvent what we had, Werner Vogel said like for S3 we have 200 microservices under the hood. So in my imagine, like I try to imagine it like, okay, 200 microservices only for S3. So it means like maybe we have not 200 2 pizza teams for S3, but I believe more than 100 2 pizza teams. And in this situation, how we can scale, how we can communicate with different teams. And this happened in 2002. Jeff Bezos said, all teams, if you develop new application, new product, anything, you have to provide API as external, like for communication. You have contract, what you provide as a service. Like for example, if it's S3, you store object provide for you like get, put, update, so on, so on. So any services, what we create in Amazon from 2002, we have to create also API for that. And API means like contract, and other teams can consume and use this as a service. Also, based on this Bezos API mandate, these services should be possible to publish externally, I mean like for other users. For that reason, we currently have AWS. Sometimes not good documentation, but anyway. And from historical perspective, around, I believe, 2014, maybe a little bit earlier or later, like how to calculate, I see another fight. I mean, like in other words, like DevOps S3. Let's rename everyone from DevOps engineers to S3. And new interesting word from Google is also bring a lot of, good approach to development. For example, error budget, SLA, toil, like you have to work to reduce toil as much as possible, automation, and also responsibility that you build it, you run it, like you're fully responsible for what you create. But as already mentioned, just like DevOps engineers does not exist. And the main reason why, because if you look at the CloudFormation, it's like Amazon style, CNCF from Cloud Native, they provide landscape where you can select different tools, like different products to solve your to set up your process, to solve your problem. And I don't want to say like, hey, let's look deeper and see how many cars here. For that reason, I prepared like more than 1,000 open source products. It's not commercial, it's open source product, which you can use also by some additional commercials. But anyway, it means like how many knowledge you have to know just like to set up some development process, DevOps, and all of this stuff. Again, it's not possible to put in one head. It's not possible. If you ask me, for example, I work almost 2 years for Amazon, and if you ask me to say, please write down all AWS services, no. The same stuff related to the open source, more than 1,000 open source products. So it's bring us again to idea of cognitive load, how we consume the information and how we interact with other people to create the right product. I want to spend a little bit time related to the cognitive load. What's exactly cognitive load and what kind of cognitive load do we have? Exists 3 different types. The first one is intrinsic. Intrinsic, it's your skills, your computer science skills, like your fundamental knowledge. For example, if you Java developer, it means like cognitive load intrinsics, it will be how to create Java class interface, how to inherit and so on, how to write loop in Java, for example. The second one, externals. It's again example related to the developer. I'm a developer, I'm front end, I'm from JavaScript, I'm from Rolling Scope community, yeah. I don't care about Kubernetes, but I have to deploy to Kubernetes. And I have to spend some time to understand how it works, what I should do to deploy my application to Kubernetes. So we try to avoid and to minimize as much as possible of this cognitive load. And the last one is germane, it's your business domain. Like you create some application, some business domain, and you have to spend as much as possible time to make sure that this cognitive load is your primary cognitive load, because when you create your application, you have to understand how this application works. And if to summarize, I would say on the first place is German cognitive load. You have to make sure that you have the right knowledge. I mean, like new tools appeared on the market, new frameworks, new languages. You still have to learn something new every day, like every month, every year, to be up to date and to be competitive on the market. But external load, like how you can interact with something, what you are not really care, like to deploy to Kubernetes or deploy to AWS. It's not your job. I mean, like if some person say, hey, we are fully responsible for Kubernetes, for me, for that person, I know externals. Cognitive load will be how to authenticate, for example, using some frameworks, or how to write, I don't know, like some method in JavaScript and so on. If you're interested about cognitive load, super recommend this YouTube video from Joe Pierce, if I pronounce the name, Hacking Your Head. Very interesting, just like 30-40 minutes. It was related to cognitive load, but how we build our teams, what kind of team topologies exist, I mean, like if we try to spread them on different categories. Exist 4 main team topologies. The first one is a stream aligned team. It's super important because this team create a value. I mean, like it's a delivery team, a feature team, doesn't matter how to call it, but this guys is working on what we will deploy, what we will deliver for our end user, and this user will see this functionality. The second team, it's enabling team. Enabling team, it's the guys who working in R&D department, who figure out that this new framework from JavaScript, I know 2002 JavaScript framework, super important and we have to implement it. So it's the guys who make some research and implement it across your organization. For example, for stream aligned teams, they help them, how to work with this super fancy new JavaScript framework. Complicated subsystem team. These guys who require some super deep dive technical knowledge and really restricted area, like for example, mathematical, technical expertise, and so on. It can be, it's your internal consultant, how, for example, banking system works, or how to data science guys, and so on. So like it's the teams who has knowledge which it's very difficult to get like in a few seconds to just Google, and that's it. And the last one, platform teams. And I believe from that started platform engineering and all of this stuff. But we're still speaking about teams, how we organize these teams in, in organization, like in org pod. I believe you see different, connections, how, for example, Google, how Facebook, how Amazon do org in their structure. And if you try to create architecture from microservice perspective, I believe you're familiar with Conway's law. Conway's law said, like, if you have some connection in your organization, like real organization, financial department communicate with account department, or some storage department communicate with sales department, and so on. And if you don't replicate the same communication channel, your application will fail 100%. This law exists more than 60 years, and still implement. You have to worry about that if you want to make some architecture vision on any application, because when we create microservice like communication, it's only one part, but you also have to think about how teams will communicate, because it's also part of convey law. So you architect, you're drawing something, make some connections, and so on, so on. But there is a question, how these teams communicate with each other? What kind of interaction models exist? And there is, again, like three main approach how teams communicate. The first one is collaboration. It's super classical. It's easy to understand. Like, for example, microservice 1 have to speak and collaborate with microservice 2 because we are doing the same product, and we have to align and sync, make sure that functionality will be aligned, will be delivered at the same time. The second one, X as a service, like we communicate with another team, but we don't collaborate them. We don't speak with this team. We consume their functionality, like through the API contract again the word API, and it's still communication, it's still interaction with this team. And in case if I need extended functionality, like in AWS we can create pull request, not pull request, PRFRQ, and requested new functionality. And the last one, facilitating, is, I believe it's not very understandable. Let me explain on example. You have enabling team, yeah? This enabling team decided like we will standardize our deployment process for the whole organization. And this enable team will facilitate with other service team or streamline team to make sure that we use the same approach, the same frameworks, the same deployment process, and so on. It's a very short period of time engagement, but solve the problem, reduce some bottlenecks, and all of the stuff. So just to summarize, we have 4 different teams, and one of them is platform teams. And as already mentioned, for that reason, I believe in my mind that people started to think, hey, maybe we have to create platform engineering and think what we are provided as a service, call it like platform engineering. And currently it's not like a hype as generative AI, because about generative AI, just like everyone speak every day, and yeah, but if you look at the community of DevOps SRE, you will have that platform engineering is like next step. And 1 year ago in Gartner hype cycle, first time platform engineering appeared. It's here, very close to design ops and Git ops. So it's like hype. Not technology, hype, trend, like what you should to aware about that today to make sure that tomorrow maybe you will apply and implement. And what another interesting fact that just 2 weeks ago when I prepared to this presentation and made my research, I got the first state of platform engineering report. So it means like community seriously prepared and make some research, prepare the report where you can find about salary, how guys who works as platform engineers earn money to compare with DevOps, SRE, and so on. What's the current state of the market, how many organizations implement platforms, and so on. And my questions here is like, it's silver bullet. So if I don't have platform in my organization, it means like I will lost the whole market and will not be competitive with other players on the market. It's my real silver bullet or not. And as usual, just like as engineer, I prefer to start from definitions. I mean, like read what exactly platform engineering means. And again, in the same report, I figure out the official definition, what exactly platform engineers. I'm really sorry for so much amount of text on the slide, but I highlighted important words. And important word for me, it's self-service. We provide some self-service for whom? For software engineers. And what exactly is this self-service? It's a product, internal development platform, but it's a product, and we cover operational. So it's very huge definition, but the keywords self-service, software engineers is our target audience. We provide a product, internal development platform, and operation. And the mission of platform engineering, like based on the definition, it's building a reliable workflow that enable developer self-service. And again, the keywords here is self-service. So you create something, and software engineers, developers can consume your product, your platform through the self-service. And with platform engineering, one of the biggest challenge is related to standardization. I still remember one of my projects where I played the role as solution architect, system architect, and I try to standardize amount of technology which we are use across for this client. It was really, really difficult because when you say, hey, we have to use for CI only GitLab CI, some of the teams say, we want to use Circle CI or GitHub Actions, or maybe, I don't know, some from AWS because we already implemented and so on. But in reality, platform engineering try to have a balance, standardize the tools, standardize the platform, the services, what they provided internally, because you cannot create platform for everything. I mean, like, you cannot create platforms for Kubernetes, for your CI/CD. I mean, like, good example of CI/CD instruments. You cannot create platforms for all CI/CD instruments which exist on the market, because we remember from landscape, CNCF landscape, we have more than 1,000 cards, and it's like in every category you have at least like 20, 30 possible variants what you can select and implement the same stuff. But when you harmonize, I mean, like, you innovate through the harmonization, when you standardize your tools, your approach, it can bring more value because you will save a lot of time. And anyway, just like based on our definition, we understand that platform is a product. And when we want to create a product, first of all, what we have to start is like super common, I believe, it's minimal valuable product. But in platform engineering, they call it thinnest valuable platform. It's like something super small. And like when I first time, just like when I made this research and try to understand what I can call like step 0, but it will be my platform, yeah. I figure out that you can create a good documentation and it will be your platform. I mean, like, for example, you have CI/CD or infrastructure as code approach. Let's do with infrastructure as code. You already written some Terraform models or something like that, and you provide these Terraform models for your developers who can create some another resources and provide a good documentation how to use it, what kind of parameters are available, what you can do, and how you can create the infrastructure what's required for developers, for software engineers. And documentation can be the first step. But in reality, it's like step 0, which is not a product, yeah, because we remember in definition it's self-service, but also it has words product. And when we are developing some products, again, we introduce the same stuff, software development lifecycle. We have to plan, collect requirements, and this I want to super highlight, guys, that when you start to develop your platform, you should not to skip these steps. Your target audience, your clients, it's software engineers. Collect the requirements from your software engineers. Maybe they don't need what you're going to implement. Maybe you focus on many stuff, many things, which is not required for your end users. Apply the same approach what you're doing in the normal situation. I mean, like in the project, in the product, what you're developing, and so on. And as usual, just like it's very, very common from AWS, and at the end, I will ask you also, listen to your customers. And your customers, your software engineers, understands what the requirements, what they ask, what they don't ask, collect feedbacks from the customer. It's a main approach when you create some product, when you create a platform. For me, very good analogy of platform engineering and in general, what is a platform? It's a car, yeah. For example, in the car, I believe you know that like some of the automotive company, create a platform, and then only to change some visual from head, like different styles, different internals, and so on, like different functionality, but create different models of the car. The same stuff happened here. And there is a question, just like DevOps, is that in this situation or not? And Again, in my personal opinion, I would say definitely not, because we still have to create a product. And product we implement through the DevOps methodology approach, best practices, collect feedback. We need to monitor. We have to, you remember, like in definition of platform, we also said like operations. We have to support this platform. And in DevOps approach, you also have to support your products and your platform. And I want to share, like it's almost done, I mean like almost done from my presentation, but I want to share with you some examples, some my project where I was involved and try to build like platforms, implement platform engineering and all of this stuff. First example, it's, I would say it was failed, it was not success. Let's review why. So project number one. I will not share the name of the customer, NDA as usual, but anyway. So we have some amount of service teams or streamlined teams, feature project teams, doesn't matter. I don't remember, like 7, 10 teams. And I said like, okay, let's create 3 different teams. CI, CD teams, like who will be responsible for Bamboo in our case. The guys who are responsible for infrastructure as code for cloud provider and write everything what's needed for developers. And BAU team, a little bit explain what is BAU team. BAU team, it's a guys who was responsible for support. It's one person with database knowledge, and he knows how to optimize, how to migrate, how to do all magic with databases. Quality engineer and developer who can fix and like do all stuff for maintenance the application. And why it was not success from my perspective currently? Because we did not provide self-service. Every time when service team needed to do something, they communicate with people, like with team, through the collaboration, and just like come to the Dmitry, for example, and say, hey, we need new resources in our cloud provider. Please create for me a new EKS cluster or some storage or database. In platform teams, the keyword's self-service. It means like developers can do it by themselves and don't involve and spend some time from other teams. So it's like failed, it's not the right approach. But it was a good start, I mean like it's a good step 0 because we create a good documentation, and when developers needed to make some adjustment or changes, they was able to do it. The second project, almost the same stuff from left side. I mean, like again, multiple teams, many projects at the same time, and I, as like system architect, DevOps engineer, doesn't matter how to call it, try to create some service because I understood I have a very small amount of people who can support CI/CD system. I mean, like to create all pipelines for all of this amount of people, and I said, okay, we will write GitLab models like GitLab functions to make sure that, like if you need to build your application, you will need to write only 3-5 lines of YAML code and that's it. If you need to run unit tests, we are already prepared for that. If you need to run integration tests, again, we already knows how to do it, and for you provided like super small amount of what you have to write by yourself. It was integrated with the good documentation, and the service team created by themselves new project like for front end, for back end, and create CI/CD pipelines by themselves. We supported only, you know, like a core functionality and try to create a real platform. Kubernetes, and also we provide as platform Kubernetes, written Helm charts. And again, guys, if they needed to deploy something to Kubernetes, they use Helm charts, our resources and so on, and just like we totally supported and was responsible for Kubernetes. Again, self-service. It was like pretty good example how you can do it and implement platform engineering in your situation. And the last one, and I believe it's ideal project what's related to the platform engineering, it was the e-commerce customer, and it was really huge, like competitive to Amazon, I would say. And our goal was to provide Spark as a service for other teams. Teams, when I say teams, it's not like 10, it's like 100 teams. And we did like real product development. We started from investigating what exactly we need, how many resources we need, and so on, so on. And it took around 9 months for me, and then I left Epam. So anyway, I still have communication with the guys who successfully deploy and release, and it's real self-service. People just say, I need deploy Spark inside the Kubernetes. Kubernetes can be located in on-premise and 2 different cloud providers, and define only some couple amount of parameters, variables, like where to run, how many resources do you need to provide, where is the storage, and so on, what the connectivity should be available, and so on, so on. And it was real good, ideal example when you need to create platform in this scale. And it was success, in my opinion, again, because it was big customer, like it's huge customer with 100, maybe not 100, but around 100 external software developer teams who needs to run Spark inside in Kubernetes. Just run Spark, but we decided to run inside in Kubernetes. So to summarize, magic number is 7. So in our mind, in our head, this 7 pieces of stuff we can collect, we can proceed. If you just look at the, for example, ChatGPT, you had, I believe, about tokens, 4,000 tokens can be proceed with ChatGPT. We are not a robots. Only 7 pieces of something we can do it. For that reason, we create, some another abstraction group of something and so on. It's our limitation as a person. For that reason, we have to limit this cognitive load. We don't have to go inside for every technology and open cloud native landscape and evaluate all of these pieces of functionality or open source products. We currently understand that exist 4 different team topologies. Service team, enabling team, complex team like consultants team, let's say platform teams. We remember about convey laws. It's very important. If you work as architect and you design microservices, don't forget about convey laws, because I saw the example when people forget about that and think only, from technical perspective. Who and when, how was the functionality will be combined, but didn't think about from people, organization, and teams how they collaborate. We also remember about interaction modes, and for that reason, people sometimes can collaborate, people sometimes can interact through the service, like use another another result of work from team as a service. And the last one, platform is a product. So when you want to create a platform, it means you have to think about on the product way. And started from very small amount, like from MVP or seen as available platform, CVP, doesn't matter how to call it, but anyway, you have to start it from some small pieces, from first steps, and to see the results, collect feedback, and so on. And again, feedback in AWS, we really want to hear your feedback. I know that sometimes people don't like to spend some time to leave your feedback, but I really ask you to just spend 5 seconds to put feedback about this presentation. And super happy if you have any questions, because for me, if you don't have any questions, it means my presentation was not very good.
Guys, if someone have a question, please put your hand on and I will bring you a microphone.
No, definitely no. And next question, please. No more questions. So it was not very interesting.
Yes,
okay.
we have.
Okay, we have a question.
Could you explain one more time significant differences between DevOps and platform engineer?
Platform engineer, it's a person who develops specific product. So in the market, we currently have front-end, back-end developers, sometimes with focus on technology area, tool set, what you know. Mostly when we say DevOps engineers, what I don't believe that exists, as you remember Unicorn, all of the stuff, we think on this way, it's a person who can write Terraform code, infrastructure as code, okay? Or write and be responsible for monitoring or observability, or for my CI/CD system, yeah. But when we create a platform, it means like we create a product, and DevOps engineer will be involved as a part of this platform team who create a platform. Yes, but platform engineer most probably will think, from another perspective, like not from do some stuff under the hood which is not available for end users, but as a developer, mostly I believe you create something what the end users can see. If you create B2C application, for example, in platform engineers, you create B2B, like you communicate internally. So the difference, long story short, the difference that you create a product, it means like write code, application code, and this application code works on the production. Mostly when you work as DevOps engineer, you don't write business logic application. I have a question. What will be the next great tool for DevOps, in your opinion? Good question. Good question. To answer this question, I will speak not like a person who works for AWS. In general, I would speak like personal opinion, like as a person, yeah. And I think it's not related to DevOps. I think it will be related to all IT. We have to focus more on soft skills, cognitive load, all of this stuff, because hard skills can be very quickly and easy, not like replace, but we will have a lot of copilots, some robots who can help to do some stuff. We don't need to remember how to make some binary tree and all of the stuff. We can quickly, like today, I can write very easy some application without huge knowledge of, I don't know, like JavaScript, for example. So in my opinion, what we will see the next, it will be related again, platform engineering, it will be a good step, because it's platform engineers, in my opinion, again, it depends on the size of the company, of course. And not for all customers, not for startups with 3 people, of course. Like if you have only 3 people and your budget like $10,000, you don't need to create a platforms at all. You don't need platform engineers. Anyway, cloud, it will be, and DevOps will need to write, and not like write, but will be able to write product code. And this code can be generated by something, but understand, read, and so on. And again, as usual, just like during the whole of my career, I would say fundamental knowledge, it's our future. I mean, if you don't understand how network works, it's a problem. If you don't know just like computer science in general, you can generate something, but you will not be able to explain and understand what's exactly there. But communication, soft skills, it's like will be more important, in my opinion, more and more important in the future. Like 20 years ago, we can see developer who just like sit in one place and do fancy stuff. Like good example, Apple. Yeah, Steve Wozniak is a person who just like to create a product inside in the garage, and that's it. In nowadays, it's not possible. You have to you have to communicate, and AI also will be support to not focus so much on hard skill, but focus on what you are doing. And I believe this vision explained from cognitive load. If you remember, I said like exists 3 different type of cognitive load, and germane, it's like what we have to focus. It's too much slides, sorry. This one. So intrinsics, you still need to save some up-to-date knowledge of technology. Anyway, just like it will be mandate. But this one is what I believe will be for all IT person. Again, it's like, I'm not a person who can see the future, but it's my own personal opinion. Another questions?
You know that for example, Jira, it is quite important tool for project management.
Yes, absolutely.
Yeah, and you mentioned
how you can start development without Jira ticket.
yes, exactly. And do you believe in future will be something like Jira or maybe 2-3 such platform frameworks which include infrastructure as a code, like Terraform, templates, and the same with CI/CD tools. So you don't need to think, for example, how to combine all of them. Just you can download this platform framework and start using it. It will be in all projects, mostly like we have, for example, now. Like we have React or Angular everywhere, or in most of projects.
No, yes and no at the same time. Yes, that I see, for example, AWS try to do it. I mean, like, for example, in Code Catalyst, they introduced Code Catalyst, just in case it's a CI/CD tool, which we announced in reInvent again in 2022. And what's one of the main functionality, it's a blueprint. When you start new project and you get like blueprint, what you need to do, it's like Terraform, in this case, not Terraform, CloudFormation code, the CI/CD pipelines, the repository where you store code, basic dashboard with something monitoring already included, and so on, so on. But do I believe that we will have some drag and drop, no code, low code functionality and push one button and get functionality at all? No. And one of the main key points also from platform engineers, and what I also researched, that the guys said platform engineers did not try to create magic, that you use some platform which you don't understand how it works. If you want, you can go deeper and see the whole process. It's platform don't want to hide some functionality from you. It provides for you functionality like through the API. You communicate like as stream. Yeah, you don't know what's exactly under the hood. It's not as a platform in this understanding. If you want to go deeper, you will see like everything, so on.
Anyone else? Okay, probably.
My question to the audience, what you prefer to listen next time? I mean, like, it was good not to speak about technology, speak about process and so on. Or you as audience, like a builder, you prefer to just like to listen about hard practices, not best practices from AWS, some hard code, and in general to show them and so on. Okay. Cognitive is better. Okay. Okay. Thank you very much.
Yeah. Thank you again, Victor. As usually, really great presentation, and I hope not last time here with us. Yeah.
As usual, just like based on your feedback,
yeah, guys,
and your invitation, if you just like put only 1 star, no, sorry.
No, we usually put 2. Yeah. Again, thank you, Victor. You can take your place. If someone else can have any other question, you can ask Victor later. And unfortunately, again, same story as with pizza, we have only offline Kahoot options for today. And I want to thanks again for all our global audience to be with us today, and hope next time we will try to organize some kind of hybrid meetup like today. And stay with us, subscribe to our social media in the description. And unfortunately, I need to say goodbye for everyone. We will end our stream. And for our offline audience, let's stay for a couple more minutes. We have our great friend from Rolling Scope community. Let me introduce him. It is Maxim Shilov, which organized for us as usual, I believe, again, interesting Kahoot quiz, and it's great chance for everyone to win some gift from us, from Epam, some Amazon credits, and it's will be not so long. It's up to 10 minutes, I would say. If I believe everyone has experience with that. If no, you just can download Kahoot application. You can connect Wi-Fi if your broadband connection not really stable. You can find a hotspot name here. It's like OFO and password OFO forever probably. Yeah.
Music licensing reimagined. Artlist.io. Music licensing reimagined.